All right, guys, for this lesson, we're going to try a slightly different way of sharing the information with you. So we're going to work on example 1 here. Population of mice quadruples every 6 months. If a mouse nest started out with 2 mice, how many mice would there be after 2 years? Write an equation and then use it to solve the problem. All right, so first thing, we're repeating multiplication here. Okay, anytime you hear that, anytime you realize that it's repeated multiplication. Okay, that means it's exponential. Okay, repeated addition or subtraction is linear. Repeated multiplication is exponential functions. So the base exponential function is this. That probably looks a little bit familiar to you from the last test, that question number 11. And remember, again, this means b is going to be multiplied times itself a certain number of times. You can also put parentheses around it to show it so that you realize it's only the b value that is raised to the power, not the a and the b value, which is what some of you missed on that last quiz question. So in our example, we need to know what these things are. So a is your initial value. Initial value. So it's the amount you started with. Okay. B is called the base. And it's the basically what you want to think about here is it's the rate of growth or the growth rate. Could be decay depending on the situation. We'll talk about what that means and how that can be different. But it's the growth or decay rate. So we should put that, we should put or decay. It's the rate at which the population is going up or down, or the amount is going up or down. And then lastly, we have T, which is time. And I'm also going to write this because it's very important. We'll talk about it too. It's intervals. It's not just a number for time. You actually have to understand what the time intervals are. So we'll get into that in a little bit. So let's start by talking about this particular problem and see if we can identify what's going on here. If a mouse nest started out with 2 mice, started out with, keyword there, started out with 2 mice, that is your A value, your initial population. So y equals 2. All right, and then we got to figure out what B is and X. So growth rate or decay. So what's the rate at which the population is changing? All right, that goes back to the first sentence. A population of mice quadruples every 6 months. Okay, quadruples means it's being multiplied, being multiplied by 4. It gets 4 times bigger every 6 months. So that's our base. Our base is going to be 4. Okay, now the next thing we need to figure out is our interval. This is where it starts to get a little tricky because it's happening every 6 months. So it happens, it quadruples every 6 months. But we want to know how long that's going to, we want to know how many times that's going to happen. How many intervals is that going to be over the course of 2 years? All right, so 2 years is 24 months. Okay, y'all can't see that. Let me bring it over here. 2 years is 24 months. So my question is, if it happens every 6 months, how many times will it happen in 24 months? Well, 24 divided by 6 is 4. Okay, so it'll quadruple 4 times. Okay, so that's going to happen 4 times, which means my X or my T, I should have put a T up here. You'll see it sometimes with X like you did on the quiz, but a lot of times if we know it's time, which it usually is, it'll be a T. So just be aware that variables can change a little bit. So our T is the number of times that we'll be quadrupling, which in 2 years will be 4 times. Okay. All right. So to calculate that out, we actually want to use our calculator here. And what this means is 4 to the 4th power means 4 times itself 4 times. All right. So when you do that, what you get is y equals, remember order of operations says I need to do this exponent first, 2 times 256. And again, I got 256 from doing 4 times 4 times 4 times 4. And then lastly, to multiply that out, you get 512. Now, what does that mean? After 2 years, there will be 512 mice. And of course, that's assuming a situation where nothing has happened to any of these mice, right? We're assuming an ideal situation where none of the mice are dying or anything like that. None of that's mentioned in the problem, so you don't account for any of that. So after 2 years, the population will be about 512 mice. Okay, that's the most basic type of exponential we'll have to deal with. Again, always make sure you're careful with the time piece because that's where it can get a little tricky. All right, moving on to example 2.